This section, we're going to talk about fundamental of probabilities. Here we have two formulas. One with the theoretical probabilities. The other one is empirical probabilities. Both of them is number of outcomes. So number of outcomes that event happened, right? On the numerator will be the same. Denominator will be also same. The difference is going to be total number of possible outcomes versus observed outcomes. Okay, because it's different case. But basically, in order to find out the probability, you're going to find the number of outcome and event on the numerator versus the total number. And that's the notations we're going to use. So let's look at example 1. Example 1 is asking a dice is rolled. Find the probability of rolling 3. So in order to find denominator, you need to know how many outcome is possible when you're rolling a dice. So a regular dice is what they're talking about. It means you have 6 sides, right? 1, 2, 3, 4. Size of having 1, size of having 2. So you have 6 sides. Out of 6 sides, when you're rolling, it means that you can get 1 through 6. So that's the total outcomes. So total outcome is 6. And in order to get 3 is 1 out of 6. So that's your probabilities. So this one is 1 out of 6. What about if the probability of rolling even number? Even number, how many even numbers? So we know that rolling a dice right here, we can get 1, right? Well, let me just show it like that, 1. Or you can have 2 or 3, 4, 5, and then 6, right? This is all different size of the dice. So this is options. So you have total of 6 sides. And even number, you're going to have 1, 2, 3 even number. Out of 6, you have 3. And when you reduce, it will be 1/2. And that's going to be your probability of getting even number. What about if it's a number less than 5? Less than 5 is going to be 4, 3, 2, 1. So it's not going to include 5. Less than is starting from the number smaller. So it'll be 4, 3, 2, 1, which is going to be 4. So this is going to be 4 out of total number, which is 6 outcomes. And again, you need to reduce that. That gives you 2/3. What about probability of rolling a number less than 10? Well, if you're looking at the possible outcome, they're all less than 10. So it could happen 6 times. 6 times out of 6, which is 1. And 1 is going to be biggest number when it comes to probabilities. Your probability should be less than 1. It's like a percentage. This 1 is same as 100%. Okay? And it means when you're looking at 0.5, 1/2, this means you have 50%, right? What about E? Probability of rolling a numbers greater than 6. Well, the dice only have all the way up to 6. So probability of rolling a greater than 6 is going to be 0. There is no number greater than 6. So you're going to say 0 over 6, which is going to be 0. So that was example with dice. What about if we have a card? Okay, so example 2, you are dealt one card from a standard of 52 cards. Find the probability of being dealt a king. So what will be the probability of getting king when you have 52 standard card? So then 52 card. I think this is the first exercise we're talking about the standard 52 card. We have 4 different shapes, right? We have 4 different shapes, and each shapes have 13 card. Number 1 through 10, and you have a king, jack, and queen. So that makes it 13. And out of 4 different shapes, 2 shapes have red, the other 2 shapes have black. So if we're looking at this example right here, getting king, it means that each shape have king, so there will be 4 king inside that 52 card. So 4 out of 52. When you reduce, it will be 1 over 13. And hearts. Remember, hearts have 13 cards. So each shape have 13 cards. So there will be 13 different cards. So there's chance of getting 13 over 52, which is going to be 1/4. What about a king of hearts? King of heart is just 1. So we have 4 king. Remember, we have 4 king, and there will be only 1 king in a heart. And that means you're going to have 1 out of 52 options. Example 3. In 2010, there were approximately 242 million Americans aged 15 or older. Table shows that distributions by marital status and gender of these populations. So the table is given right here. If one person randomly selected from the populations in a table, find the probability to the nearest hundreds that the person is divorced. So let's look at where is the divorce is. This is the divorce right here. We have married, never married, divorce, widows, and total of that numbers in male or female, right? And then you have on the bottom another total of male and female of married, never married, divorce, widows. So then let's look at, so this total right here is going to be total of all that. Either directions you add, this is going to be total, right? So go back to the problem. It say, find the probability that the person is divorced, right? Person is divorced. It didn't say male or female, so we're going to look at the total number right here. Out of 242 millions. So we're going to use round number, so it will be 242. So it will be 24 over 242. And if you round it, it will be 0.10. So about 10% if we wanted to change it. And if we wanted to change this to percent decimal into the percent, you know you're multiplying by 100. That's how you get 10%, right? But since they're asking you to write it in a probabilities, that will be your probabilities. Or even fraction form, you can reduce that. What about what will be the probability that person is female? Female. Where is female? So we have all this female. 65 married, 34 never married, 14 divorce, 11 widow. So this is total of the female. This didn't say divorce female or widow female, right? It just say female. So that we're going to use the total out of this total right there, right? So it will be 124 over 242, which when you round, find the decimal, it will be 0.5. And look like about half, right? But they're not asking for percent, they're asking for probability, so it will be 0.5. C, what about the person is going to be never married? Has never been married. Has never been married. Never married is right here. This is never married. Again, they are not asking female never marry or male never marry, so you're going to use the total 74. So that's going to be 74 over 242, which is about 0.31 probability.